Hello everyone. In this video we're going to continue to work on factoring quadratic trinomials of the form ax squared plus bx plus c. But in this video we're going to deal with cases where a does not equal to 1. In our previous video we learned how to handle these when the lead coefficient a is 1. Those are the simplest type. Now we'll look at what we need to do if a is not 1, and we'll use a method called the FOIL method. If you recall, we learned a way of multiplying two binomials of this type by a method which we call the FOIL method when we learned how to multiply polynomials. We realized that the term that comes first in the result is going to be the product of the first term and the first term here, and the last one here was the product of the last term here and the last term there, and the middle term could be obtained by taking this inner product and adding it to this outer product, which gives us 4x plus 3x and therefore 7x. That's where the name FOIL comes from. The middle term being the sum of the outer product and the inner product. Now, so if we want to factor an expression like this, we'll use this understanding of FOIL. So basically, we're not going to have this factorization on the right, but this is the way we're going to reason and try to find it. We're going to look for two expressions whose product gives us the first term. We're going to look for two numbers here whose product gives us this number in the end. And we're going to make sure that also this inner product and that outer product add up to the middle term, which is 7x. Now, a lot of students, they get this part and this part correctly, but because they do not check the final check of making sure the inner product and the outer product result in the middle term, they miss the problem. Because remember, there is going to be more than one way that you can have two numbers give you 6x squared, for example. So this is why we always make sure we do our check at the end. And also, the cross method that we used when a was 1, the lead coefficient was 1, remember we had a quick shortcut that we used. We made sure that we looked for two numbers whose product was the last number here and whose sum was the coefficient of the middle term. This will no longer work because the a here is not 1. So we will not be using the cross diagram in this section. So how do we factor these if we don't use that diagram? Well, first of all, like in any other problem, we make sure that if there's a non-1 GCF, we factor it out. We notice here the GCF is 1, so no worries there. A, notice, is 2. That means we cannot use the cross diagram, okay? And at the end, we're always going to do our 3-step check, which we've talked about. Make sure the first term times the first term gives us the first term of the expression. The last times the last will give us the last term here, and the outer product and the inner product, they add up to the middle term. So basically we start out by just opening two sets of parentheses, and this is primarily done by trial and error. So we look for two expressions whose product gives us 2x squared, right? So this is easy. Since 2 is a prime number, we can either put 2x here and x there, or we could put x here and 2x there. Either one can work out okay. Now, here we're going to look for two numbers whose product is 1. Notice I'm not worrying about signs yet. We'll deal with signs later. Now we take care of the all-important middle term. So we want this inner product, which is x, and the outer product, which is 2x, to add up. This is what we want. We want their sum to be the middle term, which is positive 3x. That's the first time we introduce a sign. Now, can we get positive 3x from x and 2x? Of course we can if they're both positive. So now, as long as you've written the inner product on the top there and the outer one on below it, then this sign will go here and this sign will go there. So now we're going to check it. Remember, we always do the 3-step check. First times first is first. Check. Last times last gives us the last one here. Check. The inner product is positive x. The outer product is positive 2x. They add up to give us positive 3x. So we've done it correctly. As long as you do those 3 checks, that's as good as you actually doing a diagram and doing a complete check by multiplying this out completely. So, but this can be done very quickly. So that's the nice thing about it. We can verify it very, very quickly with this quick 3-step check. Let's go ahead and try this one. Definitely try it on your own now that you know kind of what needs to be done before you come back to the video. All right, welcome back. You notice that the GCF is 1. They have nothing in common other than 1, these 3 terms. And the A is 6. So that means we cannot use the cross diagram. Sometimes if both of those are the same, we can factor it out and end up with an A, which is 1, and then use the cross diagram, but not when this happens. Okay, so we go ahead and open 2 sets of parentheses. Remember, we're looking for 2 expressions whose product is 6y squared, right? Now remember, there are different ways of getting 6y squared, right? So let's, for example, let's try 6y and y, right? That product is 6y squared, and we want 2 numbers whose product is 6. So why don't we try like 2 and 3, just for effort, right? Notice the inner product will now be 2y, the outer product will be 18y, right? So what we want a combination of negative 13y. Is there any way you can combine 2 and 18 by, manipulating the signs in order to get negative 13y? And your answer is no. There's no way you can do that. That tells you that those choices that we made were not correct. This is why I was telling you it is so super important to do the middle term analysis, because otherwise, if you just look for 2 numbers whose product is the first term and 2 numbers whose product is the last term, that's easy to do, but that's often not enough. It's this getting the middle term which makes these problems kind of challenging. All right, so this was our first attempt and it didn't work. Okay, so now we'll just open a new pairs of parentheses, and why don't we, instead of trying 6 and 1, why don't we try 3y and 2y. Okay, now the more you do these and the less dependent you have allowed yourself to become on calculators, the better you're going to become at guessing these. All right, so now we want 2 numbers whose product is 6. Now if I put 3 here and 2 here, right, I can do some of this in my head. I realize that if I put 3 here, that's 6. If I put here, that's another 6. There's no way I can get 13 out of that. But what if I put the 2 here and the 3 here? Now notice what the inner product is. The inner product is 4y. And the outer product is 9y. Remember what we want. We want the sum of those to be negative 13y, right? So is there any way we can get negative 13y from 4y and 9y? I think you know there is, if they're both what? Negative. Okay, so again, if you put the inner product on the top and the outer product below it, this sign will go here and this sign will go there. This is how we deal with the signs, okay? And notice that we always do the 3-step check at the end anyway, just to make sure. Notice first times first is first. Last times last, -2 times -3 is +6, which is the last number there. The inner product is -4y. The outer product is -9y, and they combine to give us -13y. So we've done it correctly. So make sure you can handle this on your own before we proceed. All right, so let's go ahead and take a look at this problem now. Of course, we always start by checking the GCF. We notice here again it's 1 and A is 12, so cannot use that cross diagram, but for the cases of A being 1, and we're going to just go ahead and dive right in and do some trials. Now, normally my own inclination when I see something like 12 is not to jump for extreme values like 1 and 12, or in some problems that's called for, but in most problems usually the more intermediate values. So maybe we'll start by trying 4x and 3x. Please, for your own sake, always try these before you come to watch, because that's the best way to learn. All right. In other words, if we were in a classroom right now, that's what you would be doing. And I never just stand there and do problems. I always make sure that you get involved. So this should be no different. If you want maximum benefit from this online situation that everyone has fallen into, you have to make sure that you try to create as much of a real classroom environment for yourself as possible. All right, so now we're going to look for two numbers whose product is 15, and we can, just try 5 maybe and 3. Now let's see. Remember, we have to check and make sure that the inner product and the outer product can combine to give us the middle term. We notice the inner product here is 15x. The outer product is 12x. And we want a combination that is positive 11x. Can we somehow combine 15x and 12x by, playing with the signs to get 11x? The answer is no. All right, this is where you have to be very careful with these types of problems. You don't want to give up on 5 and 3 as a possibility for 15 until you have tried not only 5 here, 3 here, but also 3 here, 5 there. They'll give you different results because these are different numbers. So we'll keep the 4x and 3x where they are. And this time, instead of putting 5 here and 3 here, we'll try 3 here and 5 there before we decide to give up on the 3-5 pair, okay? So we'll put 3 here and 5 there. And now we'll go ahead and try to see if we can get the 11x. So the inner product is 9x. The outer product is 20x. Remember what we want? We want a combination that is positive 11x. Now, if you notice, that's possible. If we make the 20 positive and make the 9 negative, that should work. Negative 9x plus 20x, that gives us positive 11x. Now, since we wrote it with the inner on top, outer on below, the negative will go here, positive will go here. Even though we're pretty sure this should work, we'll go ahead and do our final 3-step check, right? So we want first times first to be first, and it is. Last times last to give us last. Pay attention to the sign. See, -3 times +5 is indeed -15. We want the inner product, which is -9x, and the outer product, which is +20x, to add up to the middle term, and it does. So here is our winning factorization right there. Okay, so it's extremely important not to give up on these. And also, the second thing to pay attention to is that using a pair in one way can give you a very different result than using it the other way around. So never give up on a pair of numbers until you've tried it in both positions that are possible. All right, so here's another one. Go ahead and try this, and then when you have done your best, come back. Okay, so we notice that this is a problem in which the GCF is not 1. In fact, the GCF of 6, 9, and 6 is 3, and the GCF of u to the 5, u to the 4, and u cubed is u cubed. So the GCF is 3u cubed. So we're going to go ahead and factor out the GCF. We will wait on A for the quadratic until we actually have a quadratic in hand. So we notice that if we factor out the 3u cubed, that will leave us 2 u squared minus 3 u minus 2. Now, there's the A that we were looking for the quadratic, and it's 2, so that means we have to do trial and error FOIL method, not the big cross method. Okay, so now we're going to go ahead and just carry the 3u cubed. You always carry that because otherwise you won't get the correct answer. And now we're looking for two numbers whose product is 2u squared. So that should be easy enough. 2u and u. Two numbers whose product is -2, but we won't worry about the signs till later. So just go with 2. Now I could put 2 here, 1 here, or I could put 1 here and 2 there. Now, if we put 2 here and 1 there, think about it. That means 2 and 2. So 2u and 2u, there's no way we can get 3u out of it, right? Or -3u. But if we put 1 here and 2 there, see, some of this stuff you can do in your mind and reduce the number of times you have to repeat the process. So now if we put the 1 here and the 2 there, we notice that the inner product will become 1u, the outer product 4u. We want the combination of the inner and the outer product to be the middle term, which is -3u. So we notice that's doable. If the 4u, the larger number, is negative and the smaller one is positive. Notice +1u minus 4u is -3u. So since the inner is on top, the outer below it, the plus will go here. The minus will go there. Final 3-step check. First times first is first. Yes? Last times last is last. Inner product is +1u. Outer product is -4u. And their combination gives -3u, which is what we wanted. So there we have it, and here is the complete factorization of the problem that we saw. Notice how many terms is that? That's just one term. We had 3 terms to begin with. When we factored out the GCF, we turned it into one term already, right? But then we were able to further factor this factor this trinomial factor to get these two binomial factors as well. All right, so here we have an example with two variables. It's handled exactly the same way. The GCF actually is 1, A is 6, so we go ahead and proceed. We want two numbers whose product is 6x squared, right? So if we go with the middle ground rule, we'll try maybe 3x and 2x. And we want two numbers whose product is 20y squared, or two expressions, we should say. And maybe we can try 4y and 5y. Again, sticking to the rule that let's not go for extreme numbers to begin with. Then we'll adjust if we need to. So the inner product right now is 8xy, and the outer product is 15xy. Now, what we're hoping for is for a combination of these two, the inner and the outer products, to be positive 7xy. The question is it doable, right? Well, this can happen if the larger number 15xy is positive and the smaller 8 is negative. So this means the negative will have to go here and the positive will have to go here. We'll now do our final three-step check. We notice that the first times the first is indeed the first. The last times the last is the last here. Pay attention to the signs, make sure they work out. Because sometimes all this can look good, but then when you do the final check, the signs don't work out. So you have to always be careful with that. Here it does. Negative 4y times positive 5y is negative 20y squared. And the inner product is negative 8xy. The outer product is positive 15xy. And they add up to give us positive 7xy. So we got very lucky here and we were able to guess them from the get-go. But sometimes you may have to try it a few times. Be patient. You'll get better and better at these the more that you do, and the more that you wean yourself off of dependency on calculators for simple calculations. Okay, so here we have another one. We're going to go ahead and try it. So we're going to look for two expressions whose product is 2x squared. 2 is a prime number. That shouldn't be too hard. So 2x and x. Two numbers whose product is 5. So notice we either have a choice of 1 here, 5 here, which we can try. That would make the inner product x, the outer product 10x. But we want a combination that is positive 3x. There's no way we can get it from those two. So maybe we should try 5 here and 1 here, right? So here you'll get 5x in the middle, and for the inner product, and 2x for the outer product. You want positive 3x, and this is where you need to be really careful, because maybe if the 5 is positive and the 2 is negative, we can get our positive 3x. But that's going to put a positive here and a negative here. This is why the three-step check at the end is so crucial. Because if you do that, you'll realize first times first is first. But last times last is not last. So this kind of looked like it was going to work, but it didn't. And notice 1 here, 5 here, or 5 here, 1 here are the only possibilities, right? We've basically exhausted all possibilities and none of them worked. This is one of those polynomials which is not factorable. We call it prime. But remember, as I mentioned in the previous video toward the end, we have a check for primeness that you should definitely perform so that you don't quickly dismiss problems as being prime. The check we do is we calculate this expression d, which is b squared minus 4ac. Now in this problem, notice a is 1. Of course, we're talking about the form ax squared plus bx plus c. So notice a is a is 2, b is 3, and c is 5. So when substitute 3 for b, we get 3 squared minus 4 times a, which is 2, times c, which is 5. So we get 9 minus 4 times 5 is 40. Now, we don't really even need to evaluate that because all we need to know is that it's negative, but it's easy to do, so we'll do it. Now, this is not a perfect square. If these quadratic trinomials are going to be factorable, then this expression here will be a perfect square. You'll find out why later, but for the time being, just take my word for it. If you want to make sure that you're not dismissing a factorable problem as prime incorrectly, always do this check. Find b squared minus 4ac, make sure it is not a perfect square. Now, if you find it and it happens to be a perfect square, meaning 0 or 1 or 4 or 9 or something like that, a perfect square, then you have made a mistake and you need to go back and check to see what happened and how to factor it properly. So never give up on a problem and call it simply prime without doing this check to be on the safe side. Now here's a problem we did a few minutes ago. We can do this check on it so you can see. If we find d, first of all, notice a is 12, b is 11, and c is negative 15. So d, which is b squared minus 4ac, this is called the discriminant, becomes 11 squared minus 4 times a, which is 12, times negative 15. We'll just type that into a calculator since these are larger numbers. So we have 11 squared minus 4 times 12 times negative 15. We get 841. So we need to check to see if that's a perfect square or not. So the best way and easiest way to do that is just to find the square root of 841. So if we do we get a perfect 29. So this is 841, which is 29 squared. That's how you know this problem should be factorable, and of course it was. So this is a very easy and safe way to make sure that you're not dismissing a factorable problem incorrectly as prime, which is a common mistake students make when problems get a little difficult. They usually just go give up and say it's prime. So this way you will avoid doing that. All right, so here's our last problem for the day. Go ahead and try it before you join the video again. All right, we can see this one has a GCF other than 1. In fact, negative 5x. You agree? That's the GCF. Let's factor it out. That leaves us what? 2x squared plus 3x minus 9, right? Let's make sure that's going to give us negative 10x cubed minus 15x squared plus 45x when we distribute. So yes, we've done it correctly. So now we're just going to carry the negative 5x and we're going to factor this part out. Shouldn't be too bad because the numbers aren't that large. So 2x and x, it's not actually the size. We should say the numbers don't have that many factors. They're like 9 is composite, but it doesn't have that many factors. All right, so let's try 3 and 3. The inner product here is 3x. The outer product is 6x. We want their combination to become positive 3x, the middle term. Can that happen? Can we get positive 3x from these guys? We can if the 6 is positive and the 3x is negative and it doesn't cause any problems up here. So let's try it. So that means the negative will go here, the positive here. We always have to do the check, as you noticed in a previous problem. Sometimes these things work out, but then the final check fails. So we want to make sure that first times first is first. It is. Last times last. Negative times positive is negative. 3 times 3 is 9. It works. Inner product is negative 3x. Outer product is positive 6x. They add up to positive 3x. So it worked out and we have the correct factorization. Always be patient with these. Always make sure that you look for non-1 GCFs such as that and factor them out. Don't use that cross diagram that we used in the video covering the cases where the A is 1. For these, it won't work. And always do the 3-step check at the end. First times first, last times last, inner and outer. All 3 of those have to pass for you to have factored it correctly. So that should pretty much wrap it for this section. Practice plentifully. You have to really take your time with these and become really good at them, because we're going to see them from this point forward. And stay safe until our next video.